Now, before I talk about why DynamoDB, let me give you an idea. And thanks, James, for sharing the statistics. Let me read from slide. Over the course of Prime Day, which everyone hopefully knows, where we all spend a lot of money on, Prime Day, the sources made trillion of calls to the DynamoDB API. DynamoDB maintained high availability while delivering single digit millisecond response with peaking at 105.2 million requests per second. Imagine the backend who is that massive who could deliver this kind of performance without batting an eye. Single digit millisecond latency or 105.2 million requests per second. Unimaginable, I would say. It's a huge number we are talking about. Quantify that number to hours, quantify that numbers to day, and then you will realize that how stable and performant this infrastructure is. So what we are exploring is just some of it, and probably you may not have that huge use case, but there is always a lot of saving and performance which you can get because of DynamoDB. And the good part about services of AWS is that they always mature like wine with the time. So there were a lot of features which are always being added, and we are utilizing these things, right? So that's how we will be moving forward with that. Now I have delivered this session before, so for some of you who are your repeaters, it may be little same information, but yeah, if you have any specific question, I would be happy to answer those questions as we move forward. So DynamoDB is a NoSQL database. We already discussed. It can store key value pairs. It can store documents if the need be. So that is what we would be seeing. So let's say I have information to store Harry Potter, J.K. Rowling, 12 chapter, $20 as a price. We have another book called The Guide from Indian author R.K. Narayan, 18 chapter, $10 as a price. Another book called War and Peace, which is Leo Tolstoy. I do not have maybe information about its price and the number of chapter. Another book, Freedom in Exile, 14 Dalai Lama, 14th chapter, $15 as a price, and Homo Thondo. So that was all the information I want to store. And maybe I have another one, John Milton old classic, Paradise Lost, which is like a poem which has 360 pages on that. So this is the information I want to store into my DynamoDB table. So what DynamoDB is doing, DynamoDB is performing some magic of hash function. It identifies some information, and that will be used to diversify your storage or to keep your storage or data into a different pattern. So this hash function, which is a secret sauce of DynamoDB, it would distribute your data across partitions. Partition is a chunk of storage unit or a node. When you would be utilizing your application, we would be using these information, right? So that is your DynamoDB, which you would be leveraging on. So DynamoDB will create partitions where you will not be seeing these partitions from front end, but this is behind the scene how it actually works. And maybe my book Harry Potter goes here, the guide goes here, War and Peace, and then maybe Freedom in Exile and Paradise Lost. So all this information would be distributed based on the hash function. Hash function, if you do not know, it is just a way to create some distribution of data. So there are multiple type of algorithm. I'm not saying DynamoDB uses one of them, but maybe just an idea. Let's say I have a SHA, I say 1, 2, 3, I would be getting a hash like this. So this is basically randomizing the way I am storing the data. Next number is EEE, I have a different hash value coming from it. So this is are you using here in this particular. Where is your book? Which specific book, Jamila, you are asking about? Anything? I sorry, I forgot about that. Maybe uh, Udemy. Okay, from the previous slide. Previous slide, I had a book. Oh, okay. I get the joke. Yeah, it takes me time. Probably, yeah, that is a good idea. Why not? I get the joke now. So yeah, I will add my book also. Why not? But I feel little dwarfed by mentioning my name with those type of people like John Milton and then J.K. Rowling, Dalai Lama. Maybe in next life, but not this life, Jamila. But thanks for mentioning. Thank you. Let's move forward. All right. So what DynamoDB will be doing, there are some entities which you have to think about that we have table. So this whole data is stored in a form of something called a table. So like in traditional databases, we have table. This is similar, but not exact same, because in relational databases, your table would have different communication mechanism, or that there will be different links to different table and then relations on that. But this is a plain structure of keeping information, like table, Harry Potter, the guide, War and Peace, and all. So this is a table. Table is similar to other database system. DynamoDB store data in table. A table is a collection of data, and what we store here in traditional world we call it record, but here we would call it as an item. So this is an item. This whole thing is an item, and an item contains zero or more items in that. Table contains zero or more item. Item is a group of attribute. So what is an attribute? This information we have stored is my attribute. So Paradise Lost, John Milton, 360 pages, attribute. This is what all my attributes are. Right. So I hope this is clear and how we keep. So attribute is a fundamental unit which cannot be further broken down, and that is what we store as an attribute. Now, if I'm storing this data of DynamoDB, then challenge can come if I have only one copy of the data. So if one copy is stored and if that copy is unavailable due to whatever reason, hardware failure, system failure, network connectivity, I may not be able to get my data back. So what DynamoDB is doing behind the scene, it is maintaining three copies of your data, right? Like if you remember our S3 discussion, for you and me, when I store a file into S3, it is one file or object. S3 behind the scene will create three copies of that object. Same thing happens here, that I have a DynamoDB partition which is created with multiple copies. So there is a copy 1, copy 2, copy 3. My guess is that this stores in AZA, this in another AZ, and this is another AZ, but it is not an official statement. I guess they store across availability zone for higher durability and higher availability. Right now, this is how data is stored. The challenge would come that when a write request comes, who should accept the write request? When a read request comes, who should accept the read request? So I'll focus on that options also. I would talk about write and read operation. Let's go ahead and talk about those things. So we will discuss about write or update operations. What DynamoDB will do behind the scene, it will identify one of the copy, pay attention, one of the copy would be elected as something called a leader. Now, who becomes leader? It is all taken care by DynamoDB backend. And if I remember correctly, every 90 seconds a new leader is elected. And if you want to know more on the mechanism of it, check for a algorithm which is called Paxos algorithm. So this Paxos algorithm is used behind the scene to elect a leader copy, and through that we are able to perform write operation. So as soon as the request come to write something or update something in DynamoDB, what would happen? The backend will identify who is the leader and send request of this Harry Potter price change to $15 only to the leader node. Leader node will always get every write request which is coming in, right? So once this leader gets the copy, what if it changes itself to $15 and as soon as it changes, it goes down, which means my data would be lost. We don't want that. So what happens in this case, that automatically one copy more would get that data. So leader plus one more copy would get that data. And when both of them have the data, then only we acknowledge to the request that, okay, your request has been done. You are able to then acknowledge to application that your request has been fulfilled. What data is now safe with at least two copies as we see here. So this copy and this copy, they both have the data. I hope this thing is clear and you are following along what is happening here, how a write operation is carried out. Third copy is waiting for it. So this will be eventually getting the data in some time, seconds, millisecond. There would be at some time through which we would be able to get this information to the third copy also. There should not be a problem. In some second it should get updated. Here leader is nothing but the name given to the partition created. No, not partition, copy. Copy. So Priya, this copy is leader as of now. After 90 seconds, maybe this copy will become a leader, then this copy will become a leader. I know I have put leader here, that's why it is confusing, but it is not partition, it is the copy. So I would say leader is like this, right? So leader is a copy, not a partition. All right. So this is what a write request is happening. Write request always goes to leader, and there will be two copies maintained of the write request. Third is still trying to catch up. In few millisecond, it would catch up. So what is happening here is that this is basically what we see is a eventual consistent, and then it will say in some time it will be getting the accurate data. But what is happening here is we refer as soft state of data. My data is in soft state, right? Two partitions say, sorry, two copies say $15 and the third copy says $20 as a price. So this is a soft state of my data. In some time it will be updated, but yes, this is what a soft state database is called, or this is what we call basic available database, right? So I hope this thing is clear. What factor govern how many partitions will be created? Uh, by three partition, first to a single partition and then replicated to another two. Yes, exactly. So how many partitions are created? There are some calculations Sam behind the scene. Every partition will not go beyond 10 GB. So that is one. And then I remember if correctly, so 3000 read capacity unit and 1000 write capacity unit. So if you need more than that, DynamoDB automatically will split it into different locations and different partitions will be created. It will be there. All right. Uh, all right, good. Any questions on this? Any doubts, any confusions on this? So I hope this thing is clear that how your data is clear stored. Now the request comes for read, and I have taken this example from James. Let's talk about what we call eventual consistency and call strong consistency. Let's say you go to restaurant and you pay for dinner. One option is that you could pay for dinner through cash, right? And you could pay for dinner through credit card. If I'm a restaurant owner, in both cases, I would receive the money. My money is not lost. Whether you paid by cash or whether you paid by card, I would still get it. If you are paying, you would also be paying. You would either pay that right now or you will be paying your credit card bill, but the money would be claimed back from you. In my cash transaction, that money is given to me or changes hand that very moment. I could go ahead and utilize all these things, right? So what can happen here, that we would be getting a pay by cash. That will ensure that I am getting cash that very moment. If somebody paid by credit card, it would go to different phases of bank claiming and then credit card company verification, and then eventually I would be getting the money, and what I got as a cash is a strong consistency. Highlight of my career, the master of analogies. James, you have better analogies than me, but yeah, this is a good one, very simplest one. All right, so this is paying for dinner. That's what we are trying to do here. So this is eventual and a strong consistency. Let's keep moving forward. Let's talk about how it relates to AWS, a DynamoDB. Let's see. So let's say this is my state of the database as of now. I have my two copies who are having the latest information, and the third copy is falling behind and it has a stale information which is 20. Now request comes. So with read, we have eventual read and strong read. So we have now read eventual consistency. What we will be doing here, we will be saying, okay, let me give Harry Potter prize. Okay, Harry Potter prize. Now when I say I just want to read, eventual read are default. If I do not say anything and just say give me price of Harry Potter, what DynamoDB will do, it will go to any of the copies and try to deliver me the result. Now what can happen, if the request landed on this copy or this copy, I would get $15 as a price. If the request of read landed on this copy, I would get $20 as a price. So chances are 1 is to 3 that I may get stale data. So I may get $15 as a price or I may get $20 as a price, but this is expected because we call it soft state. This is read eventual consistency, right? So I would use this method when I am not very concerned about the accuracy. I am more concerned about the performance of my read request. I want to just read it. I don't care is it the latest or stale information. I just want some data. That time I would use eventual consistency, and this is the default mechanism. Second mechanism we have for read is strong. Somebody who says I want to have a strong read. I want to have a strong read. So in that case, what would happen? DynamoDB backend will perform two things. It will say, hey, out of three copies, who is the leader? It will identify the leader and then send request to the leader only. Leader requirement to become a leader is that it should have all the changes caught up with. It should have no stale data. It should have all accurate information. So what would happen now if I am talking to someone who knows everything? I would be getting the latest information, and I would always get $15 as a prize for my Harry Potter. So I hope this thing is clear. So when you read, you decide what works well for you, whether you want to read it in an eventual format or you want to read it into strong format, and how you initiate that request. Let me tell you. So read is called get item request in DynamoDB. So I am getting an item. I could be not saying anything beyond get item, that will be considered eventual. So if I want strong read, I have to use a parameter which is called consistent read. So if I set consistent read in my request to true, that would mean I would be having a strong read. If I do not specify anything, I would be getting a eventual read delivered to me. So I hope this strong and eventual is clear. Then depending on your use case, you may use any of them. Let me give a use case for that. So let's say I am maintaining a table of stock prices, right? So these are my stock prices. There would be three copies of my data. Let's talk about Amazon stock price. Let's say it is $95 as of now. All of them are having $95 as a value. Now changes happen, request comes in, and now my value of 95 changes to, let's say, 96. I would obviously go for upside, isn't it? So I change it to 96. Maybe this copy also gets 96, and this is still waiting. In a second or so it will be getting 96, but it still has 95. Now if from this table, this is my stock price table, if from this table I am reading, I could read this data for something like a news scroll, like I am displaying a ticker at the news, and that will tell me that what is the price for Amazon stock. And the same data I may read for a financial application, right? Now you tell me where I need strong read, where I need eventual read. Tell me where eventual read is okay and where a strong read is recommended. News eventual read, yes, Sam, I agree on that. And then and finance a strong read, I agree on that too. So yes, makes sense. So if I'm reading just for news scroll, I could put a disclaimer and say this data is, let's say, delayed by 15 minutes. Just giving an example. It won't be 15 minutes, but just giving a strong just idea on that. Financial application, people are paying, buying stocks, so I don't want to mess up with that, and that's why I may want to have a strong read on that case. So here I may see read eventual, no problem on that. Here I may need a strong read, so to move forward with that. So that is how things would be working. Another example, let's say here you are storing temperature of a device. So temperature is, let's say, around 12 degrees. Sorry, not dollar. I have to stop thinking about dollars, isn't it? So 12 degrees is the price. So come on, 12 degrees is the temperature of something. Now, if this is just a weather broadcasting station, now if this 12 changes to 12.01, it doesn't make much of a difference. It is just a news broadcast, or maybe I'm just displaying on a website. But if this temperature was for a ICU, a critical person I'm monitoring, or I'm maintaining their temperature, or I'm checking something for a person's life and death situation, then even this point one difference may be of worth noticing. And that's why it would make a good proposition to use strong read. Otherwise I could have used a eventual read on that. So you decide what works well for you, and you can then decide on where the strong read should be used and where your eventual read should be used, right? I hope this thing is clear and you have a better idea on strong and eventual read. Keep your questions coming. We would be happy to answer as much as we can. Now, is it expensive to have strong read? Yes, it is. We are coming to that pricing part. So yes, strong read are I won't say call it expensive, but it will consume more capacity. So we'll talk about capacity, that how cost calculation works in DynamoDB, and that would give you more idea on how the pricing works in that case. So we'll talk about that. All right. Now, DynamoDB allows you to have information stored in this format. Like these are my key value pairs, and within that key value, I can even have nested attributes. Should not be a problem at all. So nested attribute are also there, so you should be able to have nested attribute like address is made up of city, state, zip code, and you can go up to 32 level of nesting. Standard attribute are called scalar attribute, and then we can have nested attribute also in that particular case. You decide what works well for you. Now, the storage in DynamoDB is done by your partition key and salt key. So I'll keep this information into the PDF file. So check for that, and I would be happy to explain some of them. But let me now talk on the price performance ratio of it. So this whole data is discussed into previous training also. So you should be able to see this indexes and all in that. And I have included a comparison between GSI and LSI also. So you can check this also into the PDF file. By the way, the resources are available right now. I made them available last night, so you should be able to get all of these from the resources section of BESA website. Now let me talk about the performance side of it, read and write capacity. In traditional world, how a performance is measured, let's talk about that. So I want to have a database. The database will be on a server, could be physical, could be virtual, doesn't matter. That server will have operating system. Then I would have my database engine, and on that I would have a table created, right, for my employee table or a customer table or student table, whatever it is. My performance which is delivered by my table is purely controlled by the server I have. How much CPU I have in that, how much RAM I have in that, and then if I have multiple tables on that, or multiple databases and multiple table in those databases, basically in a way I am sharing that available CPU and RAM. So I can't guarantee a very specific performance for my table. My performance is always governed by the backend who is powering up the table. That is little challenging in deciding. Maybe out of that, only one table need high performance as of now. Let's say this is my user registration table. I am going ahead with a campaign, lot of user would be registering, but that doesn't mean order need to be explained, or my fraud detection has to be expanded. That is not possible in a traditional system. DynamoDB gives you that flexibility. In DynamoDB, you just create a table, and table would allow you to just have configuration done on itself, so it should not be a problem at all. So you could say, hey, my customer table would have high requirement right now, orders table would have low requirement. So I could configure performance on a table level without worrying about the backend and all other stuff. That's what a DynamoDB allows me to do. So I can have a table level performance configured for my DynamoDB, and that would help me also to keep cost at the table level, right? So let's go ahead and talk about that. So table performance is controlled by two settings. First setting is called read capacity unit, and second setting is called write capacity unit. You do not specify size of DynamoDB table. In traditional system, you would have a database created, and whatever is the disk available, that much you would be able to store. In DynamoDB, you do not have to worry at all about it. You just say what RCU and WCU you need, and we would ensure that you get that much of RCU and WCU, right? And it will be RCU is one strong read per second of two eventual consistent read per second for an item up to 4 KB. So if I configured, it would be better if I show it on a console so that you could relate the performance aspect of it. Let me go to Route 53 here, sorry, DynamoDB. So I'm on DynamoDB here, and let's say create a table. So I'm on table section, and let's say create a table called students. Okay. I would select a partition key. So let's say ID of student is my partition key, which I'm keeping as a number. So that is completely fine. And here I decide what my performance requirements are. So I could go with default. In default case, I would be having 5 RCU and 5 WCU. That's all. Or I could say, no, I want to customize these things. So I would go ahead and customize it. And through this customization, I would be able to select a very specific requirement as per my application. So I want to calculate the capacity, and this is very interesting way to understand how capacity is calculated and how your cost would vary on that. So here everything is is driven by your application requirement. You tell what exactly you need from your table, how many read, how many writes, and it is not a permanent thing. You could change it later. But let's say I decide that my application would require, my item size is 4 KB, and I would be needing 10 read per second, and I'm needing a strongly read for that. So if I need 4 KB item to be read 10 times per second in a strong consistency, I have to configure my RCU to 10, and that would cost me $2.91. That is my strong consistency, right? So I selected what my size of item is. I selected how much I want to read from, per second, and I selected the type of read I want to perform. Based on that, I would be needing 10 read capacity unit, and I will be paying 2.91 per month on this scenario. What if I say I am okay to have eventual consistency? So see this. In a eventual consistency, you would need half of the capacity. So in a second, if you can perform one strong read, you would be able to perform two eventual read. So obviously that would also bring down your cost. So here I have strong consistency. Read capacity unit is 10, and that is ensuring that I deliver this much of performance come what may. But if I am okay with eventual consistency, I won't need to configure more than 5 on that because it is just double. So in the same second, one strong read will be performed, or two eventual read will be performed on that. So that is how I could identify. So this can be configured later also. You decide on what works well for you, and based on that, you would be selecting this WC and RCU value. You do not select CPU memory. You say what your performance requirements are, and DynamoDB backend would provide you the required resources. Shouldn't be a problem at all on that case. Right. So 1:2, remember the ratio. One strong read equals to two eventual read, and then you can fine tune it as per your own requirement. Okay. I hope this thing is clear. So this was called my read capacity unit. How about write? Configuration is same, we call it WCU, but write are less confusing, isn't it? So one WCU, one write per second of item up to 1 KB in size. The box size for write is 1 KB, so be aware about that. So we have 1 KB box size, and through that we read the data. Let me go back to the console here. So if I see here, if I have a 4 KB item, that means I would be needing 4 WCU for that, because every KB is consumed by one write here, right? So if my item was 3 KB, then what I would be needing, I would be needing 3 write capacity unit. If item was 1 KB, I would be needing 1 write capacity unit. So box size for your read capacity unit is 4, whereas box size of your write capacity unit is 1. Just be aware about that. Now, you can't consume partial RCU in cases. So what if my item was 5 KB in size? So if it was 5 KB, see this strong. So I would need 20. Why? Because it is 4 plus 1, which is 2 read requested. It is not a partial read I could do. So if my item is 4, I would need 10. If my item is 3, I would still need 10. If it is 2, still 10. 1, still 10. Right? So one RCU consumes the whole 4 KB read. It is not partially done. So up to 4 KB, no issues. But as soon as it becomes 5 KB item, my read capacity unit requirement would be doubled. That's how the calculations are done. There is no partial read or write. It is the full read or write which is there. I hope everyone is getting their question answered and getting some idea on what is RCU and WCU is. And then you could have different capacity mode configure for your DynamoDB table. So here you could go ahead with on demand. On demand means, hey, I don't care. If one request comes in, fulfill that. If 1 million requests comes in, fulfill that. That is my on demand. But that can give you some surprise into the billing because your billing would be variable. You would be paying for every request comes in, whether it is 1 or 1 million, you will end up paying for all of it. So that is your on demand. This is good when you have unpredictable workload where you do not know how long the request would be, how many requests would be, no pattern idea, maybe just launched or maybe a marketing campaign. On demand is good in that case, but be aware that your bill can also be different depending on how many requests comes in. If let's say there was a mistake or there was an attack on your application, it ended up into 1 million requests, you would still end up paying for it because we would keep on adding capacity to the backend because you selected a on demand mode, right? On the other hand is called provisioned. Manage and optimize your cost by allocating read write capacity in advance. So I say I don't want that configuration that changes. I want to have a fixed amount to be paid come what may, right? I don't want variable amount to be paid. So that time I could go with provision capacity. In provision mode, I would say I would need 10 RCU, 10 WCU, whatever, and DynamoDB would maintain that much of it. Now, if I configured it to have a 10 RCU as a provisioned capacity, but I have used only 5 of them, I would still be paying for 10 because you said us to maintain that much of capacity unit behind the scene. So you would have a fixed price to pay. Even if you do not use all of it, you would still be paying the fixed price which is coming up. So it depends on what your use cases are and how you want to use these services. Flexibility is there. You can automatically also change it or manually change it or schedule this change. So when I am running a new application, maybe I am okay with on demand. I verify what is the regular request coming to my application, and then I can go to provisioned, make only that much capacity available. I can buy reservation also, so it will keep my cost lower. And if I feel that this month I am going with a variable usage, I could change it to on demand. Shouldn't be a problem at all, right? So I hope this thing is clear. So what I have done, I have added a table into the PDF. So you should be able to get more detail on what are the different provision mode, what charges are calculated, what is the benefit of it, and what it is suitable for. And if there is a floor and ceiling type of mechanism, if there, so on demand can scale to zero, no ceiling. You can go up to anything. But when you say provision, you still set up a minimum and maximum threshold on those services. So that is a basic of DynamoDB. All right. Now we could talk about the whole day on DynamoDB and still there would be more ground to cover. So I'm limiting what the basics information is, and we would be reinforcing this learning by Jamila. She would help us in getting the next thing related to the workshop on that. But last call for question. Anyone, any questions, any doubts on DynamoDB? I would share some links which is already in the resource section. Check those sections. You would have a lot of material to cover and learn from. So check some of the video presentation and some of the skill builder labs, so skill builder trainings I have added into that. Okay. So I hope everyone has followed along and learned something new. And now let me add Jamila to the stream. Good morning, Jamila.